The star's life cycle is determined by its mass. The larger its mass, the shorter its life cycle. A star mass is determined by the amount of matter that is available in its nebula, the giant cloud of gas and dust from which it was born. Over time, the hydrogen gas in the nebula is pulled together by gravity and it begins to spin. As the gas spins faster, it heats up and becomes a protostar. Eventually, the temperature reaches 15 million degrees and nuclear fusion occurs in the cloud's core. The cloud begins to glow brightly, contracts a little and becomes stable. It is now a main sequence star and will remain in this stage, shining for millions to billions of years to come. This is the stage of our Sun is right now. Red giant phase. As the main sequence star glows, hydrogen in its core is converted into helium by nuclear fusion. When the hydrogen supply in the core begins to run out, and the star is no longer generating heat by nuclear fusion, the core becomes unstable and contracts. The outer shell of the star, which still mostly hydrogen, starts to expand. As it expands, it cools and grows red. The star has now reached the red giant phase. It is red because it is cooler than it was in the main sequence star stage, and it is a giant because the outer shell has expanded outward. In the core of the red giant, helium fuses into carbon. All stars evolve the same way up to the red giant phase. The number of masses a star has determined which of the following life cycle parts it will take from there. After fusion of helium to carbon. The illustration above compares the different evolutionary paths low-mass stars like our Sun and high-mass stars take after the red giant phase. For low-mass stars, after the helium has fused to carbon, the core collapses again. As the core collapses, the outer layers of the stars are expelled. A planetary nebula is formed by the outer layers. The core remains as a white dwarf and eventually cools down to become a black dwarf. After helium fusion to carbon, in red Gaints. The life cycle of a massive star, 10 times or more than the size of our Sun. Like low-mass stars, high-mass stars are also born in nebulae and evolve and live in the main sequence. However, their life cycles start to differ after the red giant phase. A massive stars will undergo a supernova explosion. If the remnant of the explosion is 1.4 to about 3 times as massive as our Sun, it will become a neutron star. The core of the massive star is roughly more than 3 times the mass of our Sun. After the explosion will do something quite different. The force of gravity overcomes the force of the nuclear, which keeps protons and neutrons from combining. The core is thus swallowed by its own gravity. It has now become a black hole that readily attracts any matter and energy that comes near it. Thanks for watching.